All right, the next section we're dealing with is proving that lines are parallel. So kind of like going backwards from what we did with 3.2. In that section, we said, all right, if we have some parallel lines and they're crossed by a transversal, then we have all these theorems that state certain angles are going to be congruent to each other or supplementary to each other based on where they were in our diagram. We're going to go backwards with that. So we're going to say if we can show any one of those four theorems or postulates, those angle relationships exist, then we can say that the lines are parallel to each other. So we will not be assuming the lines are parallel. We will be showing it by showing one of the relationships. So when we have a picture of some parallel lines intersected by a transversal. Now, again, we're not assuming those lines are parallel right now. We're going to be showing it. If we can show that, say, a set of corresponding angles like these, if we can show those are congruent, then these blue lines are parallel. If we can show that we have these angles, alternate exterior angles that are congruent, then the lines are parallel. If we can show, the more complicated one is this last one. If we can show that these angles are supplementary, then the lines are parallel. So if we can show any one of these four relationships, that means the lines are parallel. This means that we're going to need to make a pretty clear plan about what our goals are. How are we going to do it? Which of these relationships are we going to show? And we'll start the proof backwards. We'll start from the end, kind of get ourselves, what's our end point going to be? And then think about how we connect from whatever's given to us to this final step there. All right, so let's look at some examples. So here we have a supplementary relationship. 1 is supplementary to 6. Those don't have a particular name that I know of. Yeah, they're not corresponding. They're not same side interior. They don't have a set relationship. So 1 is supplementary to 6. That means that another way of thinking that is that the measure of angle 1 plus the measure of angle 6 equals 180. All right. There are a few ways we could go about this proof, a lot of different ways. We are trying to prove R and S are parallel. Let's think about it. So we can show anything. We could show that 1 and 5 are congruent. If we could show that, that would be corresponding angles, and that would be enough. That's one option. We could try to show that like 4 and 6 are supplementary. Those are same side interior angles. If we can show they are supplementary, then the lines will be parallel. We have a lot of options here. I am going to show congruency. I think that's a little easier. So I'm going to try to show that angle 1 and angle 5 are congruent. Those are corresponding angles, and that is the way that I'm going to try to end my proof. So I'm going to kind of fill out the outline. I'm going to start with what we have. Angle 1 is supplementary to angle 6. And I know I need to end that R is parallel to S. And I said I'm going to try to do that by showing angle 1 is congruent to angle 5. And so the reason they would be parallel then is actually called the converse of the corresponding angles postulate. Remember, corresponding angles was a postulate, and so the converse of it allows us to work backwards and say, if the corresponding angles are congruent, then the lines are parallel. All right. Okay, here's my ideas. Here's what I'm thinking about in this proof. I know that 1 and 6 are supplementary. That's given to me. I also know that 5 and 6 are supplementary because they are a linear pair. If I can show that angle 1 and 6, I can also show that angle 5 and angle 6 equal 180. I can kind of put these all together into an equation that lets me show eventually that angle 1 and angle 5 are actually equal to each other, thus congruent. Um, that's my ideas here. So let's go ahead and set this up. Measurement of angle 1 plus the measurement of angle 6 is equal to 180. This is the definition of supplementary angles. I also have the measurement of angle 5 plus the measurement of angle 6 equals 180. This is the linear pair theorem. Linear pairs are supplementary. People might think about this differently. This sum equals 180 and this sum equals 180. Since they equal the same thing, I like to think about it as the transitive property that allows me to say that these two sums have to be equal. So measurement of angle 1 plus the measurement of angle 6 is equal to the measurement of angle 5 plus the measurement of angle 6. I'm going to call that the transitive property of equality, but some people call this substitution. The reason that it would be substitution is since one of them equals 180, you can replace 180 in the other equation with that sum. Kind of a similar idea, but doesn't matter. All right, here we can use the subtraction property of equality. We can just subtract the measurement of angle 6 from both sides to leave us with the measurement of angle 1 is equal to the measurement of angle 5. Again, that's the subtraction property of equality. And if the measurements are equal, that means they are congruent angles based on the definition of congruent angles. That's kind of a technical step that, a lot of times I've been pretty lenient on, not necessarily having to state both of those things, but it's technically accurate to do it that way. And there we go. We reached our desired outcome. These are now corresponding angles that are congruent. Thus, the lines have to be parallel to each other by the converse of the corresponding angles postulate. All right, one more. Yep, one more. All right, this one's a little more complicated. We have to be careful about a couple things here. We're only given that one set of these lines is actually parallel. So I'm going to mark those special here. These lines are parallel, which means I can connect a grouping of angles here to a grouping of angles here, or here to here. I cannot do the same between these lines, between L and M, because I do not know that they are parallel. It is my goal to show they are parallel. Okay, so we're given A and B are parallel. Mark that. And angle 4 is congruent to angle 2. Again, this is a situation where people do get into a bit of trouble. They say, oh, these look like alternate interior angles. No problem. They're both in the interior. They're on different sides of these lines. It's not the same transversal. We can't do that. A is the transversal. B is the transversal. No, can't do that. What I do want to do is show that 4 and 1 are congruent. These are alternate interior angles. So that's what I'm going to do. I'm going to show 4 and 1 are congruent. That's going to be the way that I show these lines are parallel. I'll show angle 4 is congruent to angle 1. Thus, L is parallel to M. These are alternate interior on L and M with a transversal of A. So this is the converse of the alternate interior angles theorem. Converse of alternate interior angles theorem. I don't know how I'm going to get to this point quite yet. I have some ideas. I think I'm going to connect 2 to 1. Remember, I could do that because A and B are parallel, M being my transversal. These are corresponding angles, same position. And if 4 is equal to 2 and 2 is equal to 1, then I can say 4 and 1 are, that's a transitive property here. This is actually going to be a relatively short proof. my givens. All right, fill in the middle. So I said angle 2 is congruent to angle 1. They are corresponding angles. And again, remember, I can do this. I can use corresponding angles here because A and B are parallel. That's given to us. M is our transversal. They're in the same position. I can use that because I know the lines are parallel. Now, since 4 is congruent to 2, 2 is congruent to 1, I can actually go straight here. 4 is going to be congruent to 1 by the transitive property of congruence, transitive property of congruence this time, because these are congruent statements, and actually very short proof. There we go, done. Since we have these angles here that are congruent, these are alternate interior angles on lines L and M with transversal A. Since they're congruent, L and M must be parallel to each other. That one was actually easier than the first one. Kind of surprising to me since there's a lot more going on here. All right, hopefully that was helpful. Send me an email if you have any other questions. Good luck on your test.